moon has always occupied a place of particular fascination in our lives, pushing imagination to escape its limits, empowering innovations that will aid society. In 1609, Galileo fashioned a homemade telescope to observe the moon's surface. 42 years later, Riccioli and Grimaldi created the basis for modern lunar nomenclature. However, due to inferior technology, interest in the moon was soon lost. Then in October of 1957, Sputnik 1, the first artificial satellite to orbit the Earth, was launched. The moon was no longer a faraway silver disk in the sky, but a tangible object that could be reached. This marked the start of the space age in which spacecrafts were rapidly launched with success. NASA, a pioneer in aeronautics research, was also formed during this pivotal time. The Sputnik 1 propelled military, technological, and scientific advancements that finally enabled humankind to start space exploration in earnest. In the 1960s, America sent several Ranger crafts to take lunar photos. Ranger 7 successfully sent back detailed pictures of Mare Nubium Sea of Clouds, which were then televised. In early 1966, the USSR landed the Luna 9, the first seamless moon landing. In May of the same year, the U.S. initiated the Surveyor missions, which relayed televised pictures of the lunar surface. Later trips collected data on soil properties, including its chemical composition. The final operations mapped the entire moon and scouted potential landing sites, which would aid in the Apollo missions. The 1968 Christmas flight of Apollo 8 was a milestone. Astronauts left low Earth orbit and reached the moon, circling for almost a day. Each of the subsequent missions took high-res photos of the moon's surface. On July 20, 1969, the Apollo 11 became the first manned mission to land on the moon in the Mare Tranquillitatis, Sea of Tranquility. Buzz Aldrin and Neil Armstrong walked for over 2 hours, collecting rocks and soil and laying out experiment packages. The Apollo missions revolutionized planetary science. The concept of early bombardment from 3.9 billion years ago is now widely accepted for all the planets, but the actual evidence comes from the study of lunar samples. In recent years, scientists have discovered that the moon contains much more than gray rock and dirt. It is a mine of untapped resources and materials. Lunar surface rocks and soils are rich in heavy raw materials which can facilitate continued exploration and development of the moon, known as inside resource utilization. Deposits of volatiles derived from the solar wind are useful for the ISRU activities. These are trapped in the shadowed craters at the poles and will provide a source of hydrogen and oxygen, primarily used for rocket fuel. Additionally, helium-3 in particular will be a potential fuel for future nuclear fusion reactors on Earth. Platinum group elements are extractable from iron meteorites that have survived impact, which can be used to build space observatories and launch pads. Many people are dependent on orbiting satellites for communication, navigation, weather forecasts, and more. The steep fee of these satellites are due to high launch costs. It takes about 20 times less energy to launch a given mass from the moon into Earth's orbit than from the Earth. The availability of resources to construct satellites on the moon can help diminish these costs. As Neil Armstrong once said, "That's one small step for a man, one giant leap for mankind." Returning to the moon will be the first step of many.